Hello my dear viewers and listeners. Welcome to Fahad's tutorial and I hope you are doing great. In this video I am going to explain about properties of alkane. I hope you know previously that alkane is a saturated hydrocarbon where carbons are connected or attached with another carbon with a single bond, and this is sigma bond. And I hope also you know that we name alkane according to the number of carbon. So you know that general formula of alkane is CnH2n plus 2. And of course in my previous lectures I explained that the physical properties of alkanes depends on the number of carbon. So I'm going to explain it later on, but before that I hope you know the general formula of alkane is CnH2n plus 2. So if there is 5 carbon, then hydrogen should be 12. So the formula is C5H12, that is pentane. If there is 8 carbon, so hydrogen would be 18, and that is octane. So we name alkane according to the number of carbon, and of course I have already uploaded a video based on the alkane naming or naming of alkane. So if you know the naming of alkane process, we can definitely study about the properties of alkane. So let's divide into two different segments. Number one, that is physical properties. The physical properties of alkane. So physical properties. Number one, very primarily we can say that alkanes are colorless. Alkane are colorless. Number two, alkanes are less dense than water. So we can say this is less dense than water. Less dense than water. Number three, we also can say that alkanes are non-polar molecules. So alkanes are non-polar molecules, and that is why it is not soluble to the polar solvent like water. So alkanes are not soluble to water. Number four, very important. Number four, you can say that a melting point and the boiling point, like this is another physical properties, is depending on the number of carbon. Suppose the melting point and the boiling point of alkanes depending on the number of carbon chain. What does it actually mean? I mean, if you see the melting point of butane, that is definitely higher than the melting and boiling point of propane. If you see the melting point of alkane or the boiling point of alkane is definitely higher than the melting and boiling point of heptane, as because the number of carbon, if you see that this is butane and this is 1, 2, 3, 4, 5, 6 hexane. So I hope you know it that each single dot represents a carbon. So there is 1, 2, 3, 4 carbon, and there is 1, 2, 3, 4, 5, 6 carbon. So if we name it 3, 4, 5, 6, 1, 2, 3, 4. So what we see that in this molecule there are 4 carbons is attached together, but there are 6 carbons. So the number of carbon increase the number of sigma bond or number of single bonds every time. So if you increase the number of carbons, so the chains also increase, and that is why it requires more heat to detach to reach its melting point, and that is why the melting point and the boiling point of alkanes depends on the number of carbon chain. The more carbon chain, the more melting and boiling point. So simply we can say alkanes has this sort of physical properties. Number one, that is alkanes are colorless. Number two is less denser than water. Number three, alkanes are non-polar molecules. So it is usually not soluble to water. And number four, the physical properties like melting point and boiling point depending on the number of carbon chain. Now if we look after the the chemical properties of alkane. The chemical properties of alkane. Simply what we can see that chemical properties, so chemical properties usually alkanes are relatively less reactive to other molecules, and that is why alkanes is called paraffin. So we can say this is less reactive, and that is why it's called paraffin. So in my earlier video I explained what is called paraffin. That means para means less, affin means attraction, so it has less attractions to each other. Number 2, in case of chemical properties, we can say when alkane is acting with, it's combustion reactions with reacting with oxygen, then it produces huge heat energy. And according to the process, this is hydrocarbon, so when there is oxidations of hydrocarbon happens, it produces carbon dioxide and water. But most importantly, it produces huge heat. So as heat is producing after combustions of alkane, that is why alkane used as a fuels. Like definitely you have heard about octane. So octane is an alkane, and these alkanes, if we just make conversions, then oxidations, then huge amount of heat is released, and that is why alkane used as fuels. Number 3, sometimes alkanes is reacting with halogens like chlorine gas, bromine water, with the presence of ultraviolet. And then some sort of substitutions happens. That means that halogens is taking place the space of hydrogen each time with the presence of ultraviolet, and that substitutions happens gradually. So chemical properties, usually alkanes are less reactive, and that is why it's called paraffin, but alkane has sort of like reactions like oxygen, that is oxidations. If we oxidize alkane, it produces huge heat. And also halogen, then it's produced haloalkanes. So this shorter explanations that chemical reactions or the chemical properties of alkane. So what we learned that in case of physical properties and in case of chemical properties. So important thing is what is going to, what is very common in case of question paper. Suppose you are in an exam hall, what is important? If you think about it, now you need to think about the chemical properties of alkane, that is chlorinations or halogenations. So alkane is reacting with halogen, suppose halogen with the presence of ultraviolet, and then haloalkane is producing. And this is a gradual reaction. How it happens? Let's take a look. Suppose this is methane. So methane, it has 4 hydrogen, 1 carbon. If it reacts with chlorine with the presence of ultraviolet, what is happening? 1 chlorine, you see that CH4, 1, 2, 3, 4. So CH4, and this is chlorine. They will substitute. Chlorine will substitute hydrogen, and hydrogen will come here. So what will be the productions? 1 chlorine is substituting hydrogen every time. What will happen? You see, first time, this is the first reaction, it has 4 stages. So 1 chlorine, 1 hydrogen, so it will be CH3Cl. So 1 Cl would come here and it will be like this, and hydrogen would come here, it will be like HCl. So each time it will produce hydrochloric acid. And you know the name of these compounds? This is chloromethane, or you can say methyl chloride. You can say this is methyl chloride, or you can say this is chloromethane. This naming is important. So you see that one hydrogen is substituted by one molecule of chlorine, one atom of chlorine. So chlorine, again, what will happen? It will take the second phase. That this chloromethane or methyl chloride, CH3Cl, again Cl2, with the presence of ultraviolet. What will happen? One chlorine will take place another hydrogen. So hydrogen will less, so it will be CH2Cl2. The formula is C. You see each time it has 4 valences. So 2 hydrogen are there, now 2 chlorine are here. So that should be dichloromethane. Dichloro, as there is 2 chlorine is attached and substitute 1 hydrogen, here it would be HCl. So now 2 chlorine is substituted by 1 hydrogen, and that would be CH2Cl2, and this is called dichloromethane. It's called dichloromethane. So simply we can say this is dichloromethane. Now you see third phase, that CH2Cl2 is again reacting with Cl2. Actually there should not be any hyphen in between these compounds. It should be CH2Cl2 plus Cl2. So again 1 chlorine will again substitute 1 hydrogen. Now it will form CHCl3 plus HCl. Now you see 1 hydrogen again is substituted by 1 chlorine. So the number of chlorine is 3 now, and number of hydrogen 1. So now we can say this is trichloromethane, or this is CHCl3, the name is chloroform. And lastly, the single hydrogen is there, it will also substitute by the last type of chlorine, that is CHCl3 is reacting with another chlorine, the presence of ultraviolet. So the last hydrogen will be again substituted and it will produce CCl4, and this is HCl, and that is called carbon tetrachloride, or you can say tetrachloromethane. Why? Because the number of chlorine is 4 here. So we can say this is tetrachloromethane. Tetrachloromethane, you can say, or you can write that carbon tetrachloride. So that is very important. Gradually what is happening here, if you look very closely, every time 1 hydrogen is substituted by 1 chlorine with the presence of ultraviolet ray. So that is called the halogenation, or that is called the reactions of alkane with halogen with the presence of ultraviolet. And these things is happening gradually, but if there is sunlight or ultraviolet ray in a bigger spectrum, then what will happen? The whole process will happen in a certain way. How? I'm just removing it. Okay, I hope you know the name. Okay. Now you think what will happen if this ultraviolet is coming in a certain way, then the whole hydrogen will be substituted by whole chlorine at a single time, that CH4, now it will be CCl4. So all hydrogen is substituted by chlorine, so 4 hydrogen will come here and it will produce 4HCl. Now you see the chlorine is 4 and here is 4, 8. So there should be 4 chlorine. So that is the total reaction I have written in a single line, where the ultraviolet ray comes in a broader spectrum and then hydrogen is substituted by the chlorine in a same way. So it can happen gradually or it can happen in a same way. So ultimately what is producing? Ultimately we can see that all hydrogen is substituted by chlorine. So every time hydrogen is already substituted by chlorine, and that is called tetrachloromethane or carbon tetrachloride. This is important. And lastly, we need to remember one thing, that methane or the hydrocarbon, aromatic hydrocarbon like alkanes, if it takes place in a combustion reaction, that is oxygen, each time it produces carbon dioxide and vapor. Always. Now you see that carbon dioxide and vapor, here oxygen 2 and hydrogen is 4. So if hydrogen is 4, we must put here 2 to make it equalize. And you see that oxygen is 2 and 2 4, so it should be 2. So one molecule of methane is oxidized by 2 molecules of oxygen, produce 1 molecule of carbon dioxide and water. In case of stoichiometry, if we look after the amount of the reactant and product, also some sort of things will come up. That is, if you just count the relative atomic mass of methane, you'd find carbon plus 4, that is 16. The relative molecular mass of methane is 16. And now you see this is carbon dioxide. So this is 12, 16 times 2, and that is 44. So we also can say that 16 gram methane is producing 44 gram carbon dioxide. So if the question comes like, if 222 gram methane is oxidized fully, then what is the amount of carbon dioxide will be produced? So then you see that 16 gram methane is producing 44 gram carbon dioxide, then 222 gram methane will produce 44 times 222 divided by 16 gram of carbon dioxide. So in case of stoichiometry, we also can use this equation. Now let's think about octane. Octane. Here you know that octane is C8H18. Think about it. C8H18 is the formula of octane. If you take considerations of octane, in case of oxidation, then it should be C8H18. And now you see this is oxygen. So you know that carbon dioxide and water will be produced. Okay, very good. Now you just think about the process of equalization. Now you see that carbon is 8, so put here 8. And you see hydrogen is 18. So to make it 18, there is also 2 is there, so I can put 9. Now you count the number of oxygen. You see that oxygen here is 2. So 8 times 2 is 16. Here oxygen atom number is 16. And here 9, oh, that is 9. So together it is 25. So 25 amount of oxygen, 25 atom of oxygen in the product side. So in the reactant side, that is 2. So how we can make it 25? If we can give it like 25 divided by 2, then it is actually 25. Okay, or what you can do, simply make it twice every time, like C8H18 plus oxygen. Now you have written carbon dioxide, not 8 actually, the carbon dioxide and water. Now you see that here some sort of fractions came out, but we need to avoid it if we want to avoid it, but this reaction is right. But if we need to avoid it, we make it put 2 here. So if I put 2, that carbon is 16. 8 times 2 is 16. So we put 16 here, and hydrogen is 36, 18 times 2. So if you put 18, now oxygen is 16 times 2 is 32 and this is 18. So here 18 and 32 together 50. So if you can put here 25 directly, then it means there are 50 atoms of oxygen. So that is the process of equalization in case of alkane oxidation or combustion reaction. When you put any types of alkanes in combustion reaction like that, so put it oxygens here and then put carbon dioxide and water in the reactant side and product side and then equalize. So this is very important. When stoichiometry, you have to calculate the relative molecular mass after equalizing the reactions. Without equalizing the reactions, the stoichiometry will never accurate. And when there is a questions in your question paper regarding this type of equations, you must equalize the reactions regarding the reactant and the product side. So I hope you understand. I have given a very simple explanation regarding the properties of alkane. After watching this tutorial, please let me know if you have any confusions or anything to let me know. Please do not hesitate to write down in the comment sections, and of course you can communicate with me through Facebook. So I am trying my level best to upload organic chemistry from the primary level, right? This is SSC and O level, and then after I will go a next level after explaining all the preliminary things regarding organic compounds. So I hope you understand the process and the alkane properties, the physical properties and chemical properties, halogenation reaction and the combustion reactions. Thank you so very much for watching, and I'm really feeling good that when I have received your some sort of recommendations and feedback. Thank you so very much. See you on the next video regarding alkenes, naming and preparations. Take care. Bye.